Hello, this is George Hayes. This is Introduction to C tutorial number 3, Variables Part 2. And to save a bit of time, I went ahead and typed up the entire project beforehand. You can download it from my website or the links shown below this. And to go ahead and start off, we're going to go ahead and make this project as compatible as possible to get least number of errors. So in others, under go back, slow down a little bit, click on projects, go down to build options, then come over and click on other options and type in -standard equals C99. C11 is not supported by this compiler or most others at this time, so we're going to go ahead and use it. And we're going to start off basically where we left off with the integers on the previous tutorial. Alright, so we got an integer d, and we got d equals 9 divided by 2, and if you enter that and run it, we're going to find out that it rounds down. Even if the answer came out to be 4.9, it would still round down to 4, as you can see up here at the very top. Alright, so close that back. Then we're going to move on to binary operators real quick. You'll want to, on your own time, look up truth tables for binary operators and find a good source on it so you understand it better. Right now my intent is primarily just to show you how to actually use it in the program. So right here we're going to go for an XOR. This is a caret right above your 6, and d equals 4, the caret 2, and what you get is the 4-bit is lit up right here, and then on this one the 2-bit is lit up, so both of those together have a 0 in opposite location, so it allows them to be tied together and become 6. Alright, where bit 4 and bit 2 are lit up on the output, and when you print it out you get 6. If we then again XOR it again with 2, you'll have instead, and go ahead and copy this down, place it in here, and now our input is already the same end from the previous one because we put d back into the value here. Alright, so we got 6 there, and then we got 2 here. So when we XOR it, we're going to actually get this bit is going to get turned to a 0, giving us a 4 only being the highlighted bit on the output. So that's the result is going to be 4. Alright, and we'll go ahead and run again, and you can see that that's the case with the XOR right there. Moving on to the AND operator, 4 and 4, right? So bit 4 is lit up and bit 4 is lit up, so of course together they combine as a union and become bit 4 on the output lit up. Alright, so we're going to look at 4 and 7. Bit 4 is lit up here, 4, 2, and 1 bits are lit here, and since the only ones that are the same on both is 4, only bit 4 gets lit up on the output. Alright, and if we run, we also see that that again falls true on both those bit 4s on both of them. So our output's 4. Alright, so moving on to the OR operator. If we OR 4 and 2, both bits, there's a 4 highlighted here and a 4 highlighted here, and gives us a resulting value of 6. If we were to, unlike the XOR, if we were to redo this again, it would just become the same value over. So because it can be either of them or both of them with that OR. That's the reason I said you need to look at truth tables. Not. Okay, the not operator, on the other hand, inverts all the truth tables to the previous 3. So when we take 4 and 2 and OR it together and put a not on it, we get an output that looks like this here, as far as with this binary output, and then it becomes inverted to this, and since this happens to be a unsigned, it doesn't have unsigned in front of it, it's a signed integer. Alright, it becomes -7 instead. Alright, bit shift left and bit shift right operators, they move your bits to left. So for example, we're starting off with bit 4 lit as far as in this value here. Alright, it's a simple one, and we're going to move it 2 bits to the left. Alright, so there's your bit 4 lit, and we're going to move it 2 bits left, positions left, and that becomes bit 16 highlighted, and bit 4 is no longer highlighted. Alright, bit 4 highlighted and bit shift right 2, and it becomes bit 1's highlighted. And if we run that again, you can see that here's the OR operators again, -7, and then your bit shift left becomes 16, bit shift right becomes 1. Alright, I'm going to move down to floating points. Alright, there's 3 types of floating point decimals as far as in system. There's a float, a double, and a long double. And prospectively, this is 4 bytes, this is 8 bytes, and this one's 12 bytes in size. And because the standards aren't completely met current time, the output, as far as we'll see down here, is slightly different. We have to use the float output. We don't have the capital L for a long double and the double and so forth. Alright, but anyway, you can see the size as far as what size the values become right there, as far as size of each of them. And for 8 and 12 bytes, as I said, I'll close that, and then I'll explain that. Actually, I'll leave it open at present time, make it faster. If we look at the first printf below those, we'll sit there and see there's a %f, and that's how you standard display for float. Alright, and we're going to display float B, which is 3.14159 right up here. And what it does is it prints it out. It's like this, and actually added a 0 on it. If we do this next one, we put a 3.2 before the F. That's saying display a minimum of 3 characters and 2 decimal places accuracy. Alright, and so it displays 2 decimal places accuracy, but there's a total of 4 characters still there because the decimal point is included in that. So it meets the criteria 3.14. Now if we go on to the next one, it's set as, display 5 with the accuracy of 2 decimal places. And well, we got 1, 2, 3, 4 just like above, but we don't have another, so it added a space in front to make the 5th character space. And then if we go down one more line, we got 3.2e in this small exponent. Alright, then you got down another one. You can leave the 3 off and just put the 0.2e, and then get exponent again with 2.4. And then just the exponent by itself is this line. And then if you come down, as far as we're going to display on the double, you can see we can actually display a good portion of it, but not the entirety of it, because if you can go up to 16 decimal places on the float, and that gives you all the way out to there. As you can see how to that's up on that 2.77 goes through the 7s and only displays 3 of that. And if we make any changes to it, which you can do on your own to see what type of effects it has, you'll notice that it won't display more, display less. And that's going to conclude tutorial number 3 and on variables. Thank you very much.